Good evening, everybody. It is Saturday night, my friends. I'm a little bit later than usual on Saturday here, but I was just I don't know. I was just caught up on things. I was just just randomly just watching crap on the internet, as I sometimes do, and just got caught in that like pit of like, oh, let's watch this thing. Oh, it's recommending this. Let's go watch this thing. Oh, it's recommending that. Kind of like it used to happen with like Wikipedia, where you just kind of you start reading one thing and then it's like 5 links to other things, and you're by time you realize it, it's 2 hours have gone by and you've got 25 tabs open. It was kind of the same thing. But I'm like, oh, it's it's past 7 o'clock. I should have been live already by now. But anyway, friends, welcome on in, everybody. Welcome. I hope everyone is doing well. Hope you're all having a good weekend so far. Hope you're healthy and happy and all of those things, kicking butt, taking names as one does. Speaking of kicking butt, last night we finished chapter 4 of the Vulcan book here. And now chapter 5 looks pretty extensive, but apparently at the end of it we'll have an actual proper solid color on the screen. I knew what I wanted to say. I just couldn't figure out the words to say it. But basically, yeah, we'll have a screen that has a solid color on it all the way down here, as you'll see. We'll have something like this, although I'll try to see if I can make it black instead of the light blue. So that'll be exciting. Honestly, after everything else, that'll be really exciting. We have, as you saw there, a ton of stuff to get through on this chapter now. I don't know if we'll get to the end of the chapter. I hope we will. But knowing me and knowing how picky I get sometimes, who knows? Who knows at this point? One of the things, though, I was working on off camera. So I did actually, I mentioned last night that I was going to just update the computer and then reboot and everything, and I've done that, and actually knock on wood, had some good luck with it. Like, I didn't have to fuddle with the opening and closing the keyboard and all that stuff to try to get the appropriate desktop to show up in the monitor and all that stuff. Like, it actually worked okay. It worked really well for a change of pace after a reboot. So that was great. Didn't have to fight with that. So that's awesome. The one thing is, though, I've been playing around with so we got G overlay here, right? So I've been playing around with the, what is this called? Mango HUD, which gives you statistics on, like, it latches on to OpenGL and Vulkan engine stuff and just kind of gives you statistics about frame time and all that stuff. And I eventually have it working here. Like, G-Overlay is now working for me. The version of G-Overlay that comes down with an apt-get is ridiculously old for Ubuntu anyway. But I was able to just bring down the tarball, and now we're at 1.2. It was like 0.92 or something, which is like wickedly old. Now everything's happy and working fine. However, and this is the weird thing, and I've seen some threads talking about this online. But I haven't seen anything. Like, I've tried a few things and I haven't quite gotten this to work. You see here, it says Vulkan, right? So it is working with Vulkan engine stuff, but I have not been able to get it to actually latch on to my OpenGL project. So what I've done is, if we look at the OpenGL one here, and I go into configuration. So I looked around and someone else had given you an idea on how to do this. So I look at this. So what I've seen online is to set an environment variable called LD preload and then have it point to the Mango HUD library and the DLSYM library, right? And then in the newer versions, it's supposedly, if you detects OpenGL, it will automatically do DLSYM. So I don't necessarily need this additional environment variable, but since it wasn't working, I thought, well, let me just do it anyway. I mean, if it's not going to hurt anything, then why not? And so I'm trying to force it on, and it's not latching on. It's not latching on to the thing. Now, what's interesting is, so I, try to run the OpenGL thing, it doesn't see it. If I've done a similar, oops, stop that. I've done a similar setup for the Vulkan side of things, right? And so if I run the Vulkan one, you'll see it actually tries to connect. Now it's not fully connecting because I'm not fully initializing correctly. So it makes sense to me that it's like, no, this is not going to work. But at least tried, right? If I do the OpenGL one, I get nothing. Like, it doesn't look like it even sees it. So that's kind of weird. I don't know. I've seen threads out there where people have had this problem with like Minecraft, which, again, I'm using a similar library that Minecraft is using, although probably a newer version. Most of them say, well, you have to give the command line option. But since I'm launching this from the IDE, I don't know where I could give it a command line option, because the IDE is launching JDK. So maybe there's something in here that I can do before launch. Yeah, there's not. I mean, maybe, and maybe this is more of a thing like once we get to the point where I'm compiling this, which we'll tackle at some point, where we get this to be an actual executable, then I can just run the whatever it's called. I always forget the name of this thing. What is the name of this thing again? Mango HUD. I can run the command Mango HUD and then the actual executable, and then it should, with the command line option, and it should attach then the DLSYM command line option. But I've set it in the G options thing to always be enabled for everything on the system, and yeah, it just doesn't seem like it wants to do it. So I don't know. I don't think I'm doing anything weird or strange. I have a feeling, based on the things that I've searched for online, that this might be just a problem that is common to like Ubuntu based systems, or even just potentially just to Kubuntu like I have, where something is overriding the LD preload environment variable or something to that effect. I don't know. So it's a little bit strange. So we'll have to, I'll just have to play around with it some more and see if I can figure something out. I mean, it's not a huge deal right now, but it would be really nice to have, just as it'd be nice to have that sort of performance metric there as we're going along, and being able to just turn that on and off. Um, use a tool that like gamers would use, kind of thing, to try to see what's going on and see the frame times and things like that, would be kind of nice, rather than having to develop something, which I'm sure, I mean, I imagine there's libraries out there that would help me get even, more statistics, like printing them out to the screen and whatnot. And that's fine and well, because I'm sure, like, just looking at, say, Minecraft, for instance, when you do an F12 in air and it shows all those statistics and stuff, I mean, it's more than likely they're using some kind of library. I doubt they handcrafted those. So I'm sure there's something similar, that I could latch onto, but it would be nice if I could use something that is something like this Mango HUD that just kind of is standalone, is something that, is freely available for people to use and just try to kind of get some statistics out of that too. You know what I mean? But anyway, again, not a huge deal right now. It is nice to see that it's working, at least with the Vulkan stuff. So, or at least it's trying to work with the Vulkan stuff. So that's half the battle, at least. So I suspect it's not anything that I'm doing in particular. It's just kind of a system-wide thing. I don't have, as far as I know, I don't have another OpenGL game on here that I could test it against. Like, I don't know if there's, I mean, there might be some native Linux game or something that runs it. I wonder, actually, does this come with games on it? It's got K Mines. But I have a feel, yeah, this is not, I doubt this is doing OpenGL or anything. That's weird. Okay. Yeah, like, I mean, I need to find something that would be using that. Mahjong, Sudoku, yeah. Patience card game, what the hell is that? Oh, it's all different. Oh, Spider Solitaire, Yukon Solitaire, Klondike Solitaire, Free Cell. Oh, that's kind of cool. It's kind of cool they have all of them in there. Might be up for some Free Cell. But anyway, sorry. Sidetrack. I assume there's probably something out there. There's probably some Linux game out there that I could download that would work on this relatively crappy machine and probably uses OpenGL or something, and I could test it on that, I guess. But anyway, it's neither here nor there right now. We got a big hurdle to go over today, so I should probably get to it. So swap chain render pass is where they want me to start. So let's go take a look at that over here. Engine graph. Swap chain render pass. Okay. All right. Well, this looks pretty straightforward. There's just a lot of things being created. So what are we doing here? We're doing, okay, so we give it a swap chain. Okay. And then it's got an ID, a memory ID for itself. Got a memory stack going. We've got attachments, which I believe is the um, image image buffer stuff, I think. The surface, yeah. So it's doing swap chain, get surface format image. Yeah, it's got the images, samples, load up, store up, initial layout, final layout. Okay. Got like a lot of magic constants here. Color reference, color attachment optimal, subpass, pipeline bind points, meaning color reference. Okay, subpass dependencies, render pass info, and then we create the render pass object, and then get the memory location of that and save it. And then when we go to clean up, we just call destroy render pass with that memory ID. Okay, well, I mean, it seems pretty straightforward, so I don't have any particular complaints about it right now. So let's do that. So what are we calling this? Swap chain render pass. So what did I call? I call it Vulkan swap chain, right? Yes. So we're going to do new Java class. We're going to call it Vulkan swap chain render pass. Okay. And all right. And then we just take in a swap chain and then an ID. Okay, and then everything done in the constructor? Yeah, of course it is. Okay, and we're doing a VK attachment description buffer. VK attachment description buffer. Is it just a, what is attachments plural? I thought so. Okay, attachment description, or, wait, am I doing that right? It's colic, right? Yeah. Colic, one stack. And then oh, they're actually doing get 0. Is that necessary, or can I just set one up immediately? Because it looks like there's a dot format here, right? Will this work this way? I wonder if that will... It's to 0. Okay, I'm gonna assume that that's not gonna set up properly if I don't do it this other way. It's just weird that this one is a little bit different, but okay. Format. Swap chain, get surface format image for it. Okay. Samples. VK sample count 1 bit. One bit? Was it 1 bit? Yeah. Load up. VK attachment load up. Clear. Store up. Store up. Store. Attachment store up store. Yep, and then initial layout, VK image layout undefined. And final layout, KHR swap chain. VK image layout present. VK image layout present SRC KHR. VK attachment reference buffer. This is what? The color reference? Wait, one stack attachment. Zero, and then VK image layout color attachment optimal. Color. What the hell was it? VK image layout color attachment. Color attachment optimal. Alright, and then what is this? Subpass? VK subpass description buffer subpass. Wait, what? Subpass description. Buffer. Pipeline bind points. Pipeline bind point graphics, was it? Yes, VK pipeline bind point graphics. And then color attachment count and P color attachments. Okay. Whoops. Color attachment count. P color attachments, color reference. Okay. VK subpass dependency buffer. VK subpass dependency buffer. Subpass dependencies. Okay, subpass dependency. Call it one stack. Oh shit. Okay. This is another weird one. Alright. So subpass dependencies get 0. Source subpass. So what is this? VK subpass external. VK subpass external. Destination subpass is 0. Source stage mask and destination stage mask are set to the same thing. So VK pipeline stage color attachment output bit. VK, there's no way I'm going to remember that. VK pipeline stage color. Color attachment output bit. Color attachment output bit. VK pipeline stage color attachment output bit. Color attachment output bit. Jesus H. Christ. They love their goddamn bullshit. Alright, that's that one. And then set source and destination. Source access mask is 0. And then destination access mask is VK access color attachment right bit. Access color attachment right bit. There we go. Okay. And then a render pass info. Oh, render pass info. VK render pass create info, render pass info. Call it on the stack. All right. Oh, S type. P attachments. Okay. S type. VK structure type render pass create info. VK structure type render pass create info. There we go. P attachments. Subpass is the subpass. And dependencies to dependencies. So that wires it all up there. Alright, now we need a long buffer. Stack that mimic long. And alright. Local utils, fail if needed. VK create render pass. Create render pass. Swap chain get device, get VK device. And render pass info, null, and buff. Yep. Okay. Cannot create render pass. And then this dot ID equals buff get 0. Yep. Okay. Alright, and then public void cleanup. Destroy render pass. Destroy render pass. The device, the render pass, and then null. Okay. ID and then just a getter on the ID. There we go. Okay. Class number 1 apparently is done here. So that's good. So what's the next one they want me to do? So talking about swap chain render pass. So format specifies the format of the image to be used. Okay, samples, number of samples of the image, in our case just 1 bit. Load up specifies what will happen to the contents of this attachment when the subpass word is used starts. In our case, we want to clear the contents, so we use the VK attachment load up clear value. Other possible values are load up load to preserve the contents of the attachment from a previous pass, or load up don't care if we simply don't care. For example, it may be sure that we're going to fill up again the attachment contents. We don't want to waste time in clearing it. Okay. Store up specifies what will happen to the contents of this attachment when Subpassword is used finishes. In our case, we want the contents to be presented on screen, so we want to preserve them. So we use a VK attachment store up store. Another option is store up don't care value with some don't care. Okay. Initial layouts specifies what should be the layout of the image of this attachment when the subpassword use starts. Images can be used for many different purposes. They can use to render into them or to use them as samplers for textures or in copy operations. Each of these purposes require different layout and memory. Therefore, when setting up the layout, we need to check that it's compatible with the usage that it's going to have. For example, or we will explain this in more detail later on. By now, in this case, we don't care about the image initial layout since we're clearing the attachment, so we just set it to undefined. Final layout specifies the layout of the image of this attachment when the subpassword is used finished. In this case, when we're done with rendering, we want it to be presented to the desired final. So the desired final layout is layout present source KHR. Any swap chain image must be in that state before presenting it. As you can see, we're not linking the attachment description to a specific swap chain image. We're just defining the properties of the attachment. The link to those resources will be done later using a frame buffer. Okay. Okay. Pass and finish the constructor. Okay. Cool. Alright, so it looks like we're on to frame buffer. Which looks pretty straightforward. Okay. So let's go find where they've put frame buffer at. Here we go. So they have a reference to the device. Although, which device are they? I guess they want the logical device, I guess. Probably the logical device. So this is the problem. They just named it device, and there's physical device and regular device. I think so. Device to them is logical device, right? Yeah. So frame buffer. So you want the logical device in there. The width and the height of the frame buffer, which makes sense. The pointer to the buffer of attachments. And the render pass. I wonder what that is. Does it say? What does render? What is that long render pass? These attachments will hold the handles of the swap chain images. We also need to include a reference. Oh, a reference to the render pass. Okay, so that's the. I thought maybe that would be the ID that we just set up. I just wasn't sure because they don't name their variables very well. I mean, they're named well enough, but it's like they're trying to hide the fact that these are pointers and memory references. Which makes sense because to a Java developer, none of that makes any sense. Because, well, it does. I mean, we have pass by reference, but pointers don't necessarily make sense to someone who's only done Java, right? Because we don't have pointers per se. They're hiding under the covers. But in C, since I've done C back in the day, Like I know about pointers, I know about dereferencing pointers and stuff. So when I see what's going on here, it makes sense to me, but I can see why they're kind of glossing over it. But for me, when I look at this, I'm like, well, these are memory references, so it makes sense. I just wish it was called out more that these are memory references, right? Because they're not really. It's not immediately obvious. Like I would put ID at the end of every one of them. Like I would say, instead of just VK frame buffer, I would say VK frame buffer ID. You know, instead of render pass, I would do render pass ID. And then that way it kind of like jumps out a little bit more as a, oh, this is not just like some number. This is a reference to the ID in memory for the thing that we've registered already. But to each their own. I mean, that's kind of a, what makes sense to me does not make sense to everybody. You know what I mean? Like it's kind of a stylistic thing, not a hard and fast rule, say. Okay, well this is, so all we're doing, we're just really just creating a frame buffer here, the frame buffer create info. There's a lot of create info structures. So I can see what like the Vulkan stuff is doing where it's got all these info structures. So down in the C code, they probably have like tons of typedef structs lying around. And they have all these info structures that they're using. So from that perspective, it's pretty consistent. But again, it's a crap ton of boilerplate, right? It's like, because you have to, like, they're expecting people to create all of these structures. And from the one hand, I can understand that they don't want to favor one particular use of the GPU over another, right? Because, you know, we're using GPUs now for compute stuff and not for graphics, you know, using it for, for mathematical operations and whatnot. So they didn't want to, like, whereas OpenGL kind of assumes that you're going to do it for graphics, right? So it kind of makes some assumptions along the way. And because it makes those assumptions along the way, it takes care of a lot of these sort of internal details. I just kind of wish that there was a layer of, like, I kind of wish that the Vulkan maintainers would have a layer above that would do something similar, where it's just like, okay, if you're just doing graphic stuff, and not even necessarily computer games, just graphic stuff in general, like, here's a layer that just makes your life easier, right? And it's an abstraction above everything else, and it will fill out all of these internal create info structures and do the needful. Because I can't imagine a world where just doing that translation or just doing that population of all these structures would somehow be slower than doing it manually. And you're not really removing the ability to do it manually, right? Because someone could still just say, well, I don't want that abstraction and just, I want to do it myself. So I just, yeah, that's the part that just sort of annoys me about it, right? It's like, they chose the bare metal solution, even though, there's obvious avenues where, like, even if they had multiple abstractions, where they had one where it's just for compute operations or one that's just for graphics operations, like, you know you could optimize your code for those things, or at least optimize it an abstraction for those things. This just feels, I don't know, it feels needlessly obtuse. You know what I mean? Because there's a lot of just kind of, I don't know. I'm trying to think of the word. There's a lot of, I would, I don't know. I don't know if it qualifies as architectural masturbation, but it feels like there's an element of, we only want the best and the brightest. It's kind of what it, like, it feels a little bit like that. Because you kind of have to, it's the thing that when I've mentored junior developers in the past, one of the things I've tried to convey to them is that when I write code, I try my best to not require the person who's going to eventually have to read and deal with that code to have a PhD in computer science, right? Like, I try to dumb my code down enough that any schlub off the street could probably figure it out if they, given the money and the time, and that's, I mean, that also helps me out at the end of the day, because 6 months from now, I go back to code that I've written, I'm like, oh, I see what I did there. You know what I mean? Like, I don't remember a damn thing. I don't remember ever writing the code, but I'll look at it and I'll go, oh, okay, I see what I'm doing there. Right? And then, obviously I'll look at it and go, oh, yeah, maybe this is too dumb. It needs to be a little bit smarter, and then I'll redo it. Or I'll come up with something completely different. I'll be like, oh, wow, I was really thinking of this the wrong way, and I've got a different idea now. That kind of thing. Like, that happens, and that always happens. Even if you write the smartest code in the world, you're going to come back to it 6 months later and go like, you know what, I could have done this better, right? So, I try to lean towards stupid as much as possible. I try to make the dumbest code I can make, without it, and still have it work and still be relatively performant. I mean, there's a lot of crimes you can get away with nowadays because processors are so good and memory is so cheap. There's plenty of poorly designed code that I've written that just kind of, you go back to it, you get a complaint that something's slow, and you go back to it years later, and it's just like, oh yeah, wow, that was a real big screw up on my part, because this could be completely improved. I'm doing way too much here. I'm looping too many times on this thing, or stuff like that. And I mean, that happens, But the more important thing there is that it worked, and it worked for a while, and then it just kind of got slow over time. When as more stuff around it was was created, or as more data was put into the system. I mean, there've been plenty of pages I've worked on where it's like, let's just get the page done and we'll worry about, the rest of it. And so you ask them, you're like, well, how many records are going to be on this page at any given time? Oh, just like 20 or 30. You're like, okay, I'm not going to worry about paging. I'm just going to throw everything out on the screen. And then like years later, someone comes by and says, yeah, that page is really slow. You're like, and you look at it and they've got like 300 items on the page. You're like, well, when I first designed this, you said there was only going to be 20 or 30 items on this page. So of course, now you've thrown 200, 300 items on there. It's slow. Like, but it's, you try not to optimize things before it's time to do it. The more important thing is that the page still worked. It's just you had to go get a cup of coffee and come back. Which, I mean, as far as things go, if the page works, at least they're happy the page worked. I mean, you just have to figure out how to make it work and be fast. Yeah. All right. So doing a frame buffer, we're creating the frame buffer info, cleaning it up when we're done, and just returning the ID. Okay. Sounds pretty straightforward. So let's do that. So we're doing I guess I'll just call it a Vulkan frame buffer. Let's bring this up here, over here. I'll just put this under render as well. I may move some classes around at some point, but I think these are all involved in rendering, so I guess it makes sense to have them under a package called render. So frame buffer, so I need logical device and an ID. Alright, so we'll do new class Vulkan frame buffer. Alright, need private logical device, private long ID. And this takes, I guess, logical device. And then I think it was width and height. Width and height. A long buffer for the attachments and the render pass ID. Okay. Int width, int height. Long buffer attachments and long render pass ID. Okay, so this dot device is device, and what do we got? Yeah, memory stack, and then frame buffer create info. Frame buffer create info. Okay. Info. VK structure type frame buffer create info. Give it the attachments, the width, the height. Layers 1. Okay. There's 1, and then render pass with the render pass ID. Okay. And we need a long buffer, and then we need to create it and grab the ID of it. Okay. Hills. Create frame buffer. Right, VK create frame buffer, yeah. Device, and then the create info, null, and then buffer. So, null, and then buff. Not create frame buffer. This.id is buff.get 0. Good, and then it's just cleanup. And 14 VK. Destroy frame buffer, device, and then ID, and then null. And then we need the getter for the ID. Okay. Again, pretty straightforward. I'm feeling I'm a little bit weirded out because like this is a long chapter, and so far they've given me some softballs here. So I don't know what's next. Command buffers. Work is submitted by recording commands, storing command buffer, and submitting them to a queue. It's time now to implement the support for these elements. Command buffers, new to be instantiated through a command pool, or need, I guess, to be instantiated through a command pool. Therefore, let's encapsulate command pool creation in a class called command pool. This definition is simple. Okay. Creating a command pool is pretty straightforward. Just set up initialization structure. Flag specifies the behavior of the command pool. In this case, we want pool create reset command buffer bit, which indicates that the commands can be reset individually. Resetting allows reusing command buffers after they have been recorded. This allows us to re-record them. If this is not enabled, we would need to create new commands and free the ones that could not be reused anymore. For simplicity, we will enable that flag, but if you pre-record the command buffers, you should disable this for performance. Even if you need to re-record command buffers and be top performant, it is recommended to reset the pool as a whole. If you opt for this approach, you should create one command pool per frame buffer image in order to avoid resetting the pool while commands are in use. Okay. Q family index selects the Q family index where the commands created in this pool can be submitted to. Okay. And then there's command buffer. Which takes a reference to the command pool that you would submit it to. Boolean primary, Boolean one-time submit. Instructor receives as its first parameter command pool where this command buffer will be allocated to. The second parameter specifies if it is a primary or secondary command buffer. Primary command buffers are submitted to queues for their execution and can contain several secondary command buffers. Secondary command buffers cannot be submitted directly to a queue. They always need to be included into a primary buffer. The use case for secondary buffers is command reuse. With secondary command buffers, we can record some commands that may be shared between multiple primary command buffers. This way, we can define fixed commands into secondary command buffers and combine them into primary buffers with other varying commands, reducing the workload. Another interesting use case is that they do not need to be tied to a render pass. We can record operations which require an active render pass without starting it. They will inherit the render pass, the starting of the render pass of the primary buffer they are embedded in. Keep in mind that you should not use too many secondary buffers since they may affect performance. Use them with care. Finally, the last parameter is a boolean that indicates that the command buffer recordings will be submitted just once, but they can be submitted multiple times. Begin recording. One time submit. Primary. There's a record inheritance info. First one. Okay. Receive no parameter is a convenience method which can be used for primary command buffers. The next one receives an inheritance info instance which is required for secondary buffers. To start recording, we need to create a VK and invoke the begin command buffer. It's not using one-time submit, but in this case, the driver may not try to optimize that command buffer since they'll only be used one time. Secondary buffers need to be instructed which render pass and frame buffer they will need to use since a render pass will not be started when recording. Need to fill up the structure with that information and solo set the render pass continue bit flag, which indicates the secondary command buffer. Oh, alright. And then clean up. Reset the command buffer. Throw up all the previously recorded commands so we can start recording again. Resetting is a good approach if your recordings change from frame to frame and you do not want to create a new command buffer every time. Any recorded draw operation can only happen inside a render pass. You'll see later on how this can be done. However, this fact is another reason to use secondary command buffers. They can be recorded independently of any render pass and thus can be reused in multiple primary command buffers. Okay, so if I'm understanding that, so when we're doing our rendering operations, which would be basically, I mean, in most cases, probably running shaders and stuff. if you do that in a primary command buffer, it will immediately trigger a rendering pass. But if you do it in a secondary buffer, the I think I think I understand what's going on. I think what they're saying is the actual recording of the commands has to happen while a render pass is active for a primary command buffer. But in another thread, if you want it to, you could record the actual rendering operations for secondary buffer and then have them already be recorded and ready to go when you then attach them to when you then trigger a rendering pass on whatever primary command buffer they're attached to. So in other words, you could probably I don't know if that I guess that helps in the way of sort of caching things, I guess. But I'm not sure how that helps as far as a game is concerned. I guess for your player character, like if you had, like if it was a first person game but you had like a third person camera, or even if it's just a first person game but you render the player character's legs, say, maybe you would put the rendering operations for the character's legs in a secondary command buffer because they're not always going to be visible. And so, like, because if you're just staring straight forward, which most of the time you are, and you're not looking down at your legs, then there's no reason to try to render them. And then maybe you would put those in a secondary buffer, and then only if they're visible would you then run that, I guess. And that way you don't have to process them at the same time as you're processing the entire scene. They're already there and recorded. They just get replayed. I guess that's how that would be used. I don't fully understand that. I mean, there's a lot here that I don't fully understand. Let's be clear on that. There's a lot in the OpenGL stuff I don't fully understand either. Like, it's just my thought process is that as I get deeper into actually doing stuff, like right now we're really in the foundational phase, right? So I'm trying to just get the fundamentals and the foundation in place. Trying to get as much of the foundation in place as I can before we get into like the more interesting stuff, the more complicated stuff. which is like rendering entire scenes and streaming in data from the file system and all that stuff. And by the time I get to that point, my hope is that as like I'll have the fundamentals down, well, I'll have the foundation laid, and then maybe as I start to try to do real things with it, I'm hoping that some of the stuff will start to make a little bit more sense. I mean, it's I haven't had the light bulb moment yet. And that's kind of one of the that's one of the most difficult things, right? When you're learning something, when it comes to, I don't know if this is the same for other things, but at least when it comes to development, for me, it takes me a long time usually to get to that light bulb moment where things just start making sense. So we'll take, for instance, lambdas in Java. Lambdas have been in Java for years now. And I've slowly tried to use them here and there over the years. But I was never quite understanding them. And it wasn't until, I would say, maybe 2 years ago, having used them off and on for like 4 or 5 years, that I finally had that light bulb moment where it's like, oh, I actually understand this now. To the most part, I've actually kind of figured it out. And it's not as difficult now for me. I still have to look things up. You still have to, you don't have an entire encyclopedia of knowledge in your brain constantly. There's really no reason to have that anymore when Google is just a few keystrokes away, right? But it doesn't take me as long now. Like I have a better concept of it in my brain. And that tends to be the way that things work for me, where I can just kind of like, it'll take me a while. I won't know what I'm doing for quite a while. I won't be confident in what I'm doing for quite a while. But then eventually it's just like having like a spontaneous shower thought kind of thing. Eventually I just kind of look at the code and I'm like, oh, I understand this now. And then stuff just starts clicking in my brain. And that's kind of the way I'm approaching this, right? It's like, I have no effing idea what I'm doing, really. I kind of get it. I kind of get the idea, but I don't know the ins and outs of it. But the more I write, the more I use it, the more I solve small problems with it as I'm going through and I'm doing problem solving and I'm looking things up and I'm going, how do I do this? How do I do that? How do I do this? My hope is that eventually I'll have that light bulb moment and I'll start to better understand how things are structured and working under the covers. So this is also why I try not to copy paste from these pages. I try to type them out myself, because if I type it out myself, I'm forced to think about it. And it also forces me to I also kind of remember it a little bit better. It's like the old trick that I used to do in school, right? Where, well, there was two tricks I used to do. One was even if the teacher wasn't making notes on the board, I might write some notes. They're not particularly readable notes. They're just like words or small phrases, something that would trigger my memory. And whenever we were reading from the textbook, I was lucky enough that a lot of our textbooks had images or flourished characters in it, something that would kind of make them set out a little bit. And so whenever there was an important point of information in there on a particular page, and a teacher had pointed out that there was an important bit of information on the page, it was easier for me to make a mental note of like, well, what image was on that page? What did that page look like? And then I could kind of reference that note in my brain and know, okay, this is the thing I was supposed to remember. And it's kind of the same thing here. It's just like by physically typing it out, I'm sort of engaging that part of my brain. It's like making mental notes about things. Also, it's enabling me to look at it and go like, well, I wouldn't do it this way. Let me do it this way. Let me name this variable something that I'm going to understand a little bit better later on, kind of thing. Whereas if I just boldface copy pasted it, I wouldn't have had that same utility, I guess. So there's that too, but it's different for everybody. Like that's just kind of how my brain tends to work with some of this stuff. All right, I have a vague idea of what they're trying to do there. So let's just do the command pool and the command buffers. I don't quite get it yet, but I'm hoping that when we get to the point where we're actually rendering stuff on screen, I'll start to understand it a little bit better. So we got command pool and command buffer, right? So command pool. All right. I like these coffee cups, but I really wish they were insulated. Well, I wish they were insulated, but also dishwashable. I have a bunch of insulated cups, but you can't put them in the dishwasher, which is really annoying, right? Like I want some really nice set of coffee cups. You know, not big mugs, just coffee cups that are insulated but also can survive in the dishwasher. I need that in my life. Because far too often, because this is what happens, right? Like I have a cup of coffee, I put it in front of me, I'm typing, I'm thinking, I'm doing all this stuff, and I'm like, oh, let me have a cup of coffee, and then it's just cold. Damn it. You don't know how many times I have made a full cup of coffee, gotten invested in something that I'm working on, went to pick it up, and I'm like, oh, it's cold. I gotta go into the kitchen, throw it in the microwave, and nuke it for a couple seconds, and then bring it back out again just to drink it. Like so often, I would be beside myself without without a microwave. It's just toss it in there for like 30 seconds and let it try to heat back up. The only problem with that is I've noticed, and maybe this is me just with my pinky in the air, but I've noticed that in the microwave it doesn't stay warm as long. So like I can warm it up, but I gotta remember to drink it fast because it will cool down a lot faster. And I don't know if that's just, I don't know if I just have to put it in longer or if that's just the nature of the beast, you know. Like if it comes straight out of the coffee pot, it'll stay warm for probably half an hour or more. But put it in the microwave, nuke it for 30 seconds. I got maybe 10 minutes until it's cold again. So it's like chug-a-lug at that point. Sorry, my nose is... my sinuses are a little bit clogged today. It's the weather. The weather does this to me all the time. The doctor actually said to me, because I showed her that my hands are all dry and cracked and everything. And actually, she prescribed a steroid for my hands. I used that last night, and it helped quite a bit. So I gotta use that again tonight. Yeah, so I grew up in a house that had radiant heat, and in the wintertime, I never had any problems with like my hands cracking or anything like that. But I now live in a house that has hot air heat, and good Lord, my hands get dry in the wintertime. It's just insane. So the doctor actually said, like, you need to get a humidifier. You need a good humidifier and just have that running. So I gotta go. I had one at one point, and I threw it out because I didn't do it right. You're supposed to put I didn't read the instructions, or maybe I did read the instructions and I said I'm not going to pay extra, so I'm just going to put regular water in it. And yeah, you put regular water into a humidifier. After a while, you're going to pretty much destroy that humidifier. And that's basically what I did. But now that I'm already buying distilled water for the humidifier in my CPAP machine. Might as well I now have the water around that you're supposed to use, so start. I just got to find one that's can do a decently sized room and just roll with that. I know that I can get one for my central heat, but my guess is that's going to be like probably 10 grand to do that, and I don't know that I want the whole house to be humid. I mean, I kind of do and I kind of don't, because with all the electronic devices I have in this room in particular, the low humidity is preferable. You know what I mean? So if I were to suddenly pump up the humidity in here, it would not, I mean, it's not going to destroy anything, but it's certainly going to put some wear and tear where there shouldn't be any. So I kind of would rather have it just find one that can sort of cover a small area. And like, I don't think I would have one in here, even though I spend a lot of time in here. It would probably make a lot of sense to have one here, but I don't want it to get into the electronics too much, so I'll probably just worry about it in, at nighttime. Just have one that'll big enough to handle the bedroom. So, and again, it's just like, it's not even, I mean, I'm already getting humidified air from the CPAP mask. So it's really just for my hands at that point. So we'll see. Anyway, sorry, I'm all off on tangents here. Command pool. So we need the logical device and the ID. Q family index. Okay. Okay. So we're creating a command pool, create info. Okay. It's sensing a pattern here. And then VK create command pool. And there's a destroy and a cleanup. Yeah. There's a get device on here. I don't. Well, okay. So we got both get device and get ID. It doesn't hurt anything, so sure. It does annoy me that we have all these references to the device. Like lying around. Because it's just like, I mean, okay, it is what it is. I mean, you need it. You need the references device in order to do the destroy command. So I get it from that perspective. It's just, it just annoys me a little bit. I'm kind of wondering if it's not better to just have a reference to the VK device instead of the full device class. But whatever, I guess. I mean, my concern there is when we're talking about memory consumption and the garbage collector and stuff, like every time you've got another reference to something, the garbage collector can't collect that, right? So you got to be really careful that like you're not leaving these dangling references around that you're not actually using for any purposes, right? Because you get into a low memory or an out of memory situation, you know, the garbage collector can't do much at that point because you've got all, you know, these classes are still being referenced. Whether that reference is useful or not. But yeah, whatever. I mean, these are fundamental classes, so I guess it's fine from that perspective. It's just I see so many classes that are just leaving these pointers around that I start getting a little antsy about it. And actually, honestly, in this case, the other thing is, I'm pretty sure this is just leaving a reference to the device here. But when it comes through a constructor, is it still passed by reference, or is it going to convert it to an actual copy? I think it's still passed by reference. I think it still ends up being a reference. And I think that's also why they're marking it as final, to kind of make sure that it stays as a reference. Because you're basically telling the optimizing compiler at that point that you're not going to change this. So it can say, all right, I don't need to make a deep copy of this class because you've marked it as final, so it's not going to, you've already said you're not going to change it, so I can just pass the reference to it and just keep one reference around. So that might be why they're have such a hard on for marking everything final, maybe. Yeah, that might be what's going on there. I don't know. That's a lot of that is sort of very internal to how the garbage collector works and how the JVM works and how the compiler works. And I know very little of that at the end of the day. I've tried to learn as much about it as I could, but the JVM changes so frequently now, and they swap out garbage collection algorithms, you know, more frequently than most people change their underwear anymore. So it's like I've completely lost the lead on it, you know. Command pool. All right, so where would this live? See, I've got everything under this one. Okay. All right, I'm gonna put it under render because I assume that's where it lives, but I don't know. And cool. Final. Device. IT. What's the other thing? Q family index. Okay, and what we got here? VK command pool, great info. Stack S type. And pool create info. Flags, command pool create reset command buffer. create reset command buffer bit, right? Yep. And then Q family index. And then create command pool. Command pool, and that is device command pool info null buffer. Okay. And then cleanup, and then getters. Okay. Whoops. Command pool. Device command pool null. Okay. Yep. Oops, that's the one too. There we go. Okay, so that's the command pool. And then the command buffer. So we have a command pool, a one-time submit boolean, and VK command buffer and boolean primary. Okay. So and buffer, right? Yeah. Command pool, one-time submit. Hey, hello, welcome on in. How are you doing, sir? So we have that. Command buffer and boolean primary. Yo. I'm doing good. I'm sorry to hear it. You still got that pain going. That sucks. That really sucks. I hope they can figure something out for you. For that, because that's oof, that's rough. That's the one thing that, like, it honestly surprises me. Um, it honestly surprised me with all the medical um, advancements we've made. It surprises me that the back is still like one of those things that we've just never quite figured out. Like when people have back pain, it's just it's like, well, we could just go in and rearrange some things and see what happens. You know what I mean? It's not like other kinds of pain where they're just like it feels like they have it on lockdown, you know? Looking into a chiropractor. Yeah, I mean, for that kind of pain, it might just be worth it. I don't I don't particularly I don't particularly buy into a lot of the chiropractic stuff, but I can't deny that a lot of people who go in there come out of it with a hell of a lot less pain. So, I mean, if it ultimately if it doesn't damage you worse and makes the pain manageable, then you know, why not go for it? Just be very careful to find a really good one. You know? Yeah, I know. I get it. Like there comes a point where it's just like you got to do something for the pain, even if it's not necessarily medically sound. You got to do something. Um, yeah, you just got to be very, very careful. You don't find like a hack job. That's gonna make things worse, you know. And always do it on on your terms. You know what I mean? Like be like, look, I'm gonna let you work on me, but you do something that I'm not cool with, we're done. You know what I mean? It's like, you know, it's like there's I'll go so far, and then after that, it's yeah, it is what it is. Because I see like they have a lot of YouTube videos out there, and I see there's one thing that always I don't understand, and I see chiropractors do this all the time, where they basically take a tool and they start scraping your skin, the back on your back, and you see these people just getting really red from it. I'm like, what the freaking hell? I would never let them do that. Like, what the hell are you doing? Like, freaking, like, it's one thing to do an adjustment, it's another thing to, like, turn somebody into a freaking raw piece of meat. Jeez Louise. But no, I mean, you know, go for it. You know what I mean? Like, you gotta do something. You gotta do something. And I mean, there's people that I've worked with who've, like, yeah, exactly. Exactly. Like, I worked with a guy who, was a cheerleader in college, and I mean he was a strong dude. Like he was, you know, he was no slouch. And he was still pretty, pretty buff. He was maintaining his exercise and all that stuff, but like all the years of like tossing chicks up in the air and catching them and all that stuff just kind of like really ruined his back. And he would go to like chiropractic stuff every couple weeks and just be like, yeah, just give me an adjustment. And he swore by it. So, I mean, that's, go for it. You know what I mean? Like if it works, you found somebody good and you can, and it helps get some of that pain out of there, then you can't really argue with that, you know? You just can't do it. Though I'll be honest that I'm surprised. I'm surprised your doctor hasn't suggested physical therapy for some of that, because that to me would seem like something the doctor would be like, all right, you've got pain, let's see if we can do some physical therapy for you, like try to get some of that, see if that helps out a little bit. Oh, he did, and you went and it didn't do anything. Oh, I see. Okay. Okay. Yeah, I mean, it is what it, yeah. Okay. Yeah, I mean, I can't argue with any of that. That's like, I understand, like, when you've got pain, it consumes everything, like it's just like living with it is not great. So I don't fault anybody at all for just like doing whatever they got to do to like take care of that, because it's it consumes your brain. It consumes your like all your thoughts, all day long. You can't, like, every time you're doing something, you can't enjoy anything because it's like it's just there. Ugh. I understand that. Believe me. Believe me, I understand that. But I hope everything turns out. He even said it was a 50-50 chance. Yeah. Well, I hope everything turns out good. Are you still were you going to get some kind of surgery for that, or was that just a they don't want to do anything yet? No, I totally get that, dude. Like, it's just like, I mean, uh, believe me, I understand. Like, there are times I'm sitting here and I can feel like my legs going crazy, and I'm like, I want to, I want to stream and I want to be happy-go-lucky, but at the same time, it's like, everything just hurts, and you're just like, okay, it's something has to give, you know. So I totally get you. I totally get you on that one. I understand. I'm lucky enough that I can just stand up and walk around for a couple minutes and usually resolve it, but that would not be the case for a back thing. Oh. I don't know how my dad did it all those years. Like, he had a bum knee for like I want to say 10, 15 years, maybe 15 years. His knee was just not good. And he did a lot of heavy lifting during the day, like at work, and he was on it constantly, and he loved to walk and everything. And eventually, like, it got to, like, he eventually got surgery on it. When they fixed his knee, like, he had no cartilage left in his knee, like none whatsoever. So they fixed it all up, and I can't imagine the relief that it was still painful for him, you know, from time to time, particularly when it would rain outside, like he would really feel it. But like, and he still couldn't kneel on that knee. Like, he had to kneel on his other knee. But like, I can't imagine the relief that he had just from that. Just from them fixing that thing. That was crazy. Alright, so let's have a command buffer here. But despite all that, how's everything else going on? Everything else okay? So command pool, command buffer, boolean primary. Taking a command pool in, boolean primary, boolean one time submit. What do we got here? Command pool. Get device, oh, that's why we did the get device on there. Sure. Okay. That's fine. So VK command buffer, allocate info. Command buffer allocate info, and this is allocate info equals S type command pool. Structure type command buffer allocate info. Command pool is get ID. Level is either primary, primary is true, then it's primary, otherwise it's secondary. Was it command buffer level primary? Command buffer level primary, otherwise command buffer level secondary. And then command buffer count 1. And then what? A pointer buffer. And then we allocate command buffers. Okay. And right. Details, fail if needed. Q14.vk create command buffer. Allocate command buffers. Of course they would call it something else. Allocate command buffers. Device. Allocate info and then the buffer. Wait, did I forget to bring the... No, I didn't. Device, allocate info, buffer, cannot allocate command buffer. All right, and then just, okay, then create the VK command buffer. Okay, so this dot buffer equals new VK command buffer. And the ID and then the device. So buff gets 0 and then that, okay, and then public void cleanup. So vk14.vk destroy. Oh wait, is that true? Oh, VK free command buffers, yeah, because it's allocate. And then free command buffers. And then that takes device and then command pool ID and then command buffer. So and then buffer. Right, okay. But that's down further. So the next thing is begin recording. Take the inheritance info, which is what we create down here, right? Render pass, frame buffer, subpass. Okay. underpass ID, frame buffer ID. Yes. Void begin recording. Void recording. Return, not return. Get recording. No. Okay. So then we do a memory stack. We build up a command buffer info. Command buffer begin info. And then we set the type, and then we have to set the flags if it's a one-time submit. If it's not primary, then check to make sure inheritance info is not null. If it is, then immediately throw up an error and exit. Otherwise, command buffer inheritance info, begin info, and then okay. Where does the begin info come in? Command buff info. Oh, I see. When we call the begin command buffer, it takes two structures. So it takes the begin info and it takes the command buffer inheritance info. Yeah, assuming it's not primary. If it's not the primary buffer, then it's a secondary buffer, so it has that additional structure to tell it what its parent is. Otherwise, that'll just be inheritance info, VK command buffer info. No, VK command buffer we just created up here, right? Oh, so that's always going to be there. So both these are always going to be there. It's just this inheritance info is getting stuffed into the command buffer begin info. Okay. All right. I see what they're doing there. I would have. I think. I think I'm going to move this part, or I'll move this part into a private method and just return this inheritance info and then put it in there. That way, because this is, as you saw, as I was reading through this kind of threw me off a little bit because I was like, oh wait, we're creating two structures, but then we're only putting one structure into here, and then yeah, okay. So I'd rather this was a private method so that it more distinguishes itself as a, okay, this is only if this is a secondary thing, and it go off, build this thing and bring it back. And then that way, as you're reading down this, you're like, oh, command buffer info, we're setting the flags, oh, we're setting the inheritance info, and then we're setting the flags here differently. If it's that's going to be interesting. So if it's one-time submit, so it looks like you can't have a one-time submit and be a secondary buffer, because it's just overriding that flag here with this. So that's interesting. Okay. Okay. Would have been good to like call that out in a comment or something too. All right, so we gotta start out with a memory stack, and then VK command buffer begin info. All right. Okay. Command buffer allocate info, was it? Begin info. VK command buffer. Begin info. VK command buffer begin info. Colic stack. This type is VK14. VK structure. Type command buffer begin info. All right, and then we're saying if one-time submit. And what is this? VK command buffer usage one time. Okay, command buffer usage one time submit bit. All right, and then if not primary. Skip that for a second. Well, no, I'll do it right now. So let's go private. What's this return? VK command buffer inheritance info. VK command buffer. Oops. Inheritance info. Build inheritance info. And do I need to pass anything in there? I need to pass the stack in there. and inheritance info. Yeah, the stack and inheritance info. So memory stack, buffer inheritance. Okay, we'll say if inheritance is null, throw new runtime exception. Secondary buffers must have inheritance information. Okay, good. And then we're saying actually build it. VK command buffer inheritance info. Info equals colic stack. I guess I do the S type, right? Yep. Oops. Structure. Type. Command buffer. Inheritance info. Render pass, subpass, frame buffer. Yes, frame buffer, and then oh, and that's it. Okay, we just have to return that. Okay. So then up here I can say if this is secondary, then begin info dot p inheritance info. Stack and then inheritance. That's a lot cleaner because now you can see it's all going. You're just building one structure here. And then flags command buffer usage render pass continue bits. VK render. Oof. Command buffer usage render pass continue bit. Command buffer render usage render pass continue bit. VK command buffer usage render pass continue bit. Command buffer usage render pass continue bit. Okay. Damn, they love their long ass flags. Okay. So I have that. So then we actually call the create to the begin command buffer. Okay. So VK14 VK create begin command buffer. Of course, it's something else. Begin command buffer, buffer, and then the info we just built up. So buffer and then begin info. And then able to create command buffer. And that's all we have to do there. Okay. And we have the cleanup that we did, and then there's end recording. So end command buffer. I'll put that here instead of after cleanup. So public void end recording. So vk14.vkend command buffer. Command buffer. I've got to wrap this in a well, if needed. Unable to end command. And then there's a reset. PK reset command buffer. That doesn't have a check on it though. Okay. PK reset. Okay, so public void reset. Set command buffer. I just give it buffer, right? And then VK command buffer reset release resources bits. VK command buffer reset release resources bit. Command buffer reset release resources bit. Command buffer reset release resources bit. Yep, okay. Alright, so that's the command pool and the command buffer. Again, deceptively straightforward. Has me a little bit concerned because there's still a lot of this chapter left here. But then again, there is a lot of explanation going on too, so there's that. Let's do the frame buffer, so we have the command buffer. Okay, synchronization. Oh boy, here we go. Here we go. We're getting closer to render something on the screen, but prior to that, we need to address a fundamental topic in Vulkan, synchronization. Vulkan will be in charge of properly controlling the synchronization of resources. This imposes certain complexity, but allows us to have full control about how all operations will be done. They keep saying this. They keep saying like, well, you know, this kind of sucks, but you'll have full control. It's like, it still kind of sucks. I will gladly give up that control if you could make this suck less. That would be great. In this section, we will address two main mechanisms involved in Vulkan synchronization: semaphores and fences. There are other elements such as barriers or events, but since they are not required at this moment, we will not develop the cover. So, fuck me. They have both semaphores, fences, and then eventually barriers and events. So are we event-based or are we semaphore-based? Like, what? Okay. Fences are mechanisms used in Vulkan to synchronize operations between the GPU and the CPU. Semaphores are used to synchronize operations inside the GPU. and are frequently used to synchronize queue submissions. These elements are used to block the execution until a signal is performed. Once a signal is received, execution is resumed. Yeah. It's important to note that signaling is always done in the GPU side. In the case of fences, our application can block waiting in the CPU until the GPU signals that execution can go on, but we cannot trigger the signaling from the CPU. In the case of semaphores, they are internal to the GPU. Waiting can only happen in a GPU. Okay, so let me see if I can figure out what that means. So if we have CPU threads running that are dependent upon the next frame being written, we can block in the CPU while the GPU is doing its thing. But if we have multiple threads running on the GPU, we can block them using the semaphore. Okay, so it's, I mean, it's basically, yeah. Yeah, so I mean, basically what I think they're saying is that if you want to block the GPU, like you need to synchronize something going on in the GPU, that blocking mechanism has to exist on the GPU side. But if you do have a thread that's waiting for something to happen in the GPU, like a frame to be rendered, you can still use a fence to stop to pause a CPU thread and wait for the fence to return a signal saying that the GPU is ready. So I sort of see what they're saying. It's again, it's like, it's layers of who really cares. Like this is one of those things where it's like, not to sound like a broken record, but this is like, these are details that really shouldn't be exposed. Like, these should be optional. These should be things that, you know, are just handled by the Vulkan driver and not first-class citizens, but, you know, whatever. So we have the semaphore class here. Which again is really straightforward. You're just making you're just creating the one structure. And then you have the fence where you're creating the fence structure, and then they have a wait and a reset. Does this have a... No, it doesn't. Okay. Okay, sure. And then it looks like we can then just integrate these with our render class. Oh, no. There's changes to queue, or they're creating a queue. Present queue. Present queue extends queue. And they're adding stuff to render. And what's going on here? They changed the swap chain stuff. They added something to swap. Oh, they added an array of queues to the... and the present queue to the swap chain constructor. Okay. And then they added an array of semaphores to the swap chain. As well as an acquire next image. What is this doing? Acquire next image, device, get VK device, swap chain, semaphores list, acquisition semaphore. Yes. Need to be properly signaled when an image is freed and not being presented. Besides that, we define. Okay. So this is just setting up a. This is letting us know when the GPU has rendered a frame and has now moved on to the next frame and has freed up the memory for the last frame, so we can start writing back to that memory location for the upcoming frame, because we're doing triple buffering. So that means 3 frames. So you've written to 1 frame. It gets pushed to the GPU. While that push is happening, you're writing to the 2nd frame. And then the 3rd frame, and then those get pushed, and then as those frames get pushed, you get notified that they've been pushed, and then you can just start to write to, because it's like a circular buffer. It's hard to the hard part there is it's hard to visualize for me when things start in time. So for instance, as far as the logic in the game is concerned, am I 1 frame ahead or am I 2 frames ahead? Because it seems to me like I'd be at least 2 frames ahead, meaning that I've written frame 1, frame 2, and frame 3, along with all the physics and everything else that would have to happen for those frames. And then as frame 1 gets pushed to the GPU, it then recycles back down to be used for frame 4, and then I'm starting to push frame 4, and so I'm always constantly 2 frames ahead theoretically, unless you fall behind, I guess, and then you start to get stuttering and stuff. That's the visualization part that I'm struggling with, but I guess I suppose it'll become, I mean, yeah, I guess it'll become a little bit more clear as we actually do something real with it. I don't know. I mean, I guess at the end of the day, it doesn't matter. Yo, dude. How are you doing? I guess at the end of the day, it doesn't really matter because it'll be... I don't know. I'll be manipulating 3D objects, so it'll be doing whatever it needs to do. We'll see. We'll see. Presentation, present image. Okay. Let's see, they've got like current frame +1. Hmm. Forward render activity. Jeez Louise. How many classes are they going to introduce here in this one section? It's like we're almost there. Image views, render pass, frame buffer, width, height. Definition of a render pass, command buffer, frame buffer. If you look at the constructor, use an instance. Command buffer. What the hell? Oh, this is where they're setting this solid color. Oh. They're applying that and then... Render pass begin info. What? Begin render pass, end render pass. You are shitting me here. So, for every goddamn frame, we gotta build another goddamn structure? Are you effing insane? Good God. Somebody was structure happy here. That's a lot. And somehow this is faster than everything else on the market. Okay. Output attachment. Command buffer. Jeez Louise. Okay, so this last section is not just like one more thing. This is like 92 more things. Great. So, but I still need to do the semaphore and the fence here, which look pretty straightforward at least. At least there's that. Let's see where we're at here. Wait, no. I want to look at the actual code. And they've got Q here. Did I do a Q already? I feel like I don't see one. Oh, Vulkan graphics queue. Yeah, base device queue. Right. Yeah, I think that's what they're doing there. I hope that's what they're doing there. It looks like they've added... Wait, what the hell? So Q... Have they added the submit? So here's graphics Q. I feel like they added submit here. Because I don't think that's something I put in there. Yeah, they definitely added that. Okay. Alright, that's fine, I guess. And there's definitely stuff that they've added to this one. Okay. Sure. Alright, well we'll get to that in a second here. So semaphore, and then that's straightforward, and then fence, and that looks pretty straightforward. Okay, start with the semaphore. Where would these go? I guess these are still part of the render pipeline. You know what? It doesn't really matter at this point. I can just put them anywhere and then move them if I don't like where they're at easily enough. So this takes a device and then it has an ID. All right. So a device and an ID. You know what? I'm going to put it under device. I'm going to put it there because I'm just going to call them. I'm not going to call them Vulcan Semaphore and all that stuff. I'm just going to call them Semaphore. Device and then ID. Oops. All right, and then a memory stack, and then create info. Okay. What the hell is it called? Semaphore create info. Okay, structure type for create info. Is that all I need to send on there? Yeah, then I need a buffer and then create it. Create semaphore and then device, the info, null, and the buffer. Okay. And then set the ID equal to buff. get 0. Alright, and then destroy it with the device, and then the ID, and then null. And I think they want a getter on the ID. Yep. All right. That was relatively straightforward. And then we got to do fence. Okay. Which is still pretty straightforward, although there's a Boolean on there. All right, cool. I need to stand up and stretch for a couple minutes because I've been going for almost 3 hours. So just give me a couple minutes to stretch my legs and kind of make some of the pain go away. So hang tight, friends. Maybe I'll get some more coffee, I think, too. All right, hang tight. I'll be right back, friends. Okay, I am back. That's good. Oh, I wanted to try something. I switched back to mix it up here, bot, and I want to see if this works.
I suppose by the transitive property, I too must be Vulcan as a motherfucker.
It does. Okay, good. Just making sure. And I think I made it so that command is available to everybody. Let me just check it here. Commands. Group random cards. Fiction. What is it? It's not under there, is it? It's that's not what I'm looking for. Users. No. Where the hell do you manage action groups? No. Not that. Oh, here it is here. Oh, yeah. Yeah, permissions user. Okay, cool. Cool. All right. I just wanted to check that. I forgot to check that was that was working. I need to get more. I have like a couple random sounds set up, but I have to get some more. Go snag some more sounds to add to that. Anyway. Cool. So we need to create a fence. And that takes the device and then an ID. And then the constructor takes the device and a boolean. Alright, so do fence. And final logical device. And final log D. Public fence. Logical device. Boolean. What was the name of the boolean? Signaled. Okay. VK fence, great info. Structure type. Fence, create info. And then flags, if signaled is true, then set the signaled bit, otherwise it's 0. VK14.vk fence create signal bit? Yes. Otherwise, it's just 0. Alright, and then we need a long buffer to store the ID. And okay, create fence device info null buffer. And ID, oops, ID equals buffer get 0. Okay, so that stores the ID off. And then we got cleanup, right? So it's probably VK14.vk destroy fence, and then it's probably device and then ID and then null. Okay. All right, so then the next one is weight for fences, and then reset, and then just get the ID. Okay. I'm going to say void weight, and that would be VK wait for fences. VK wait for fences. Yeah. Device ID true, and then long max value. So I guess that's how long to wait, which is probably infinite then. Wait forever. Okay. Device ID true. So device ID true, long max value. And then reset. Let me guess, it doesn't like that this is called wait, right? Cannot override. Oh, yeah. Reset is VK reset fences. That's device, get device, and then probably ID, right? Yep. And then they just want a getter on ID. Okay, so we got semaphore and fence done. So the next thing they want me to tackle so I guess we'll do forward render activity first, because they want me to add that to the render class. So forward render activity. All right, and I'm going to make these lists instead of arrays because, yeah, see, they end up converting them to lists in order to, so stupid. Just make them lists. It's not difficult. You know what I mean? It's really, really not difficult. So we need a command buffer, fence, frame buffer. Command buffer, fence, frame buffer. And I better call them command buffers. Frame buffer, render pass, and swap chain. Frame buffer, render pass, and swap chain. Render pass. Swap chain. Okay, and then the constructor takes the swap chain and a command pool. Then we're doing a memory stack again, and we're going swap chain get device. How many times are we using the device? So we got device here. I see. Okay, they're doing it in a couple loops. Okay. And the swap chain extent. Okay, width and height. Means that all we're doing is getting the width and height? So why wouldn't I just get the width and height? Okay, so we'll just get the width and height. And then image views, get image views. Number of images, image views dot length. Attachments put image views. I get VK image view. Number of images. Oh, it's just looping over the number of image views, so I could just do I'm putting it into the attachments. Oh, because... Wait, why? We're doing a new frame buffer. I guess P attachments has to be a long buffer, and that's why they're doing that. That sucks. Why can't I just give it just the long? Because this is a Java class that's being nude. Oh, we create a frame buffer, right? Yeah, long buffer, P attachments. Yeah, I mean, that's being pushed into there. But I wonder if that always takes that. Is there any other variant of P attachments? No, it only takes a long buffer. Well, that sucks. Because what bothers me there is what bothers me there is that we're only allocating this long buffer once, and then we're reusing it. Right, so I mean, it's a pointer to the okay. It's just that just annoys me a bit because it's like you could just give it a long, like if LWJGL did it right, they would just give it a long and just instead of a long buffer, and then you could just keep passing it that rather than going through mallocing, the extra step of mallocing and all that stuff. Because is this the only thing that we're doing a malloc long on? Like that's literally the only reason we need the memory stack right here. Is just for that. Like that's just silly. And then we're just allocating it once and just constantly reusing the same one over and over and over again. That's just silliness personified, right? It's like, just make it a regular long, and then I could just give it a long, and then you're done, right? It's accomplishing the same thing at the end of the day. Oh well. Yeah, I mean, it's just like, see, it bothers me when you have something like this, because literally this is being used for just one operation. It's not even being used in a loop, it's just being used for exactly one operation. And you've got all this other junk in there that doesn't need it. Right? But they've put all this stuff in here, which are now local scoped. They're scoped to this try. Right? So if I were to move them out of here, now they're scoped the entire method, which, I mean, it's not a big deal, but it's still like, you know, still can be triggering. You know? And then you've got this stuff here. You're creating, and this annoys me even more, is that we're then going back and looping over the number of images again. Like, why aren't these... all in the same loop? Like, you've got the attachments. Like, you could make the command buffers and the fences up here. Have the one for loop that does this, creates the frame buffer, creates the command buffer, creates the fence. And then records the command buffers, frame buffers, width and height. This was obviously a choice by the person writing the book, because I think they wanted to highlight that these are different, but that it's still stupid, right? It's like you can still highlight these by just putting extra space up in here in this for loop, right? Like, there's nothing that this is doing that they can't also do. Right, because it just makes, because me looking at this, it makes me suspicious. Like, why is this, why are we looping over this again? When we could just do it once and get everything in one shot, because all these are interrelated anyway. They're all these are building up in order to do this record command buffer call. Right? Which I guess technically we should do the record command buffer method first. And then this creates its own memory stack. This is creating its own memory stack in a loop. Like, okay, fine. You have something here that needs a memory stack. You're calling this in a loop, right? You've already got a memory stack here that you're using for fuck all except for this thing, right? Like, just pass the same fucking memory stack in here. Since you're already in this goddamn awful giant try block, just, and it's a private method, so just use it. And I got another fucking one down here for submit, but this, where is submit called? Well, this is, okay, well, this one's public. All right, so I can forgive it in a public one because this is called from outside the class, potentially. So I can forgive it there. But this is private, dude. This is only called from this one fucking class. It's this little stuff that just annoys the shit out of me. It really does. And it shouldn't, right? I should be totally fine with it, but I'm not, because I've seen so much code in my life that it's just like, it's the little stuff like this that I know 6 months from now will trip me up, right? Somehow, some way, there'll be some performance thing, and I'll be like, why is this taking so long? And then I'll look here and be like, well, of course it's taking so fucking long. You know, it's just, oh, it's the little stuff sometimes. It's also easier to read when you've got all this stuff in there because you know it's all interrelated because you're doing this. The whole point of doing this is to record it. Just take a deep breath and just and then device with height attachments. Because see, it's even like it's building the frame buffers one item at a time, which makes sense. But then it's recording them one item at a time, which also makes sense. It'd be different if like you were building all these frame buffers up and then you were passing the entire list of frame buffers in here. But you're not. You're passing it one at a time. So, which, yeah. Annoyed. Very annoyed. All right, so we need to do a memory stack. Pull out the device. We'll pull out the width and the heights instead of the goddamn whole, instead of this thing. And then the image views, we don't need to pull. That'll be the for loop. I'll just do a loop over the image views. I'll just do a for each on the image views. And because these are going to be, instead of these being arrays, they're going to be items. I'll just is there any reason to even keep these around? Like, I know we have them up here. But do we have to we have to deallocate them. Okay, so that's why we're keeping them around in the first place. All right, that's fine. So I'll just make them objects. And add them to the list at the end, right before we do record command buffer. I'll add them to their respective lists, and then we're done. Like I had time. So weird. It's so weird. Again, this is one of those things. It feels like they just ported this from like C and didn't really think about what they were doing. They just kind of ported it straight up. Okay. So we need a forward renderer here. So we've got try. One second. Man, my nose. My nose. I think I can. Can I breathe out my nose in? A little bit. A little bit. One side, anyway. Okay. Equals stack push. Chain get device. And then width and height. Where did we get these from? Extents. Wait, what? Swap chain extent. Did I forget to put that on there? Swap chain extent. Oh, I made it private. Oh, I see what's going to happen here. Let's do. You know what? I'm going to do a width and height. It's get width. There we go. That just helps even more. Get width. There we go. Get image views. All right, and swap chain render pass. Render pass equals new swap chain render pass. Okay, so I don't know why that's in there. Just do this dot render pass equals new. All right. Seems to me like that could be anywhere, so might as well put it there. So we need a long for the P attachments. So long buffer. Okay, and Frame buffer. Number of images. Don't need to do that. Alright, so we want to loop over the number of images. So we'll do swap chain get image views, right? For each. Alright, and I want to do... I wonder if it'll let me do this inside. It should let me set that inside there, I think. Well, yeah, it's final. It'll let me set it in there. It's a problem. The problem is because it's declared as final. I could declare it. I won't be able to do them as an unmodifiable list. I don't think. But I'm also not that concerned about that either. So I'm going to do this new array lists. And then down here, let me see. Frame buffer images. So view get ID, I think. So attachments. Put, whoops. View dot get ID. And then do frame buffer. Device with height attachments. And render pass ID. And then command buffer. It's command pool true false. And fences gets the device and then true. Okay. And I'll just add all these to their respective things. So this dot frame buffers, add frame buffer. This dot command buffers, add command buffer. This dot fences, add fence. Frame buffer, command buffer, fence. Frame buffers, fences, frame buffers. Buffers, frame buffers, fences. Yep, okay. And then we just do record command buffer, which we gotta write. So I'll just put to do record command buffer. And that's it. That was the loop. And the constructor. Okay. So let's do the private void. Private void record command buffer. Takes a command buffer, a frame buffer, a width, and a height. Okay. Oh, and it's going to take the stack because screw redoing the stack here. So there we go. And this is where we're setting the background color, it looks like. So vk clear value dot buffer. Value dot buffer. Value equals stack. Clear value, apply 0, and then okay, a function, lambda. So clear value dot apply 0, and then a consumer. So v dot color. So I'm guessing that's RGB A? 32. 0, 1, 2, 3. Yeah, it must be RGB and A because the alpha is set to 1, which means no transparency. And the first thing is just, I guess, the index into the quadruple, the tuple, quadruple, whatever it's called. So all these should be 0 if I want it to be black, I imagine. So float 32, 0, 0, 1, 0, 2, 0, and then 3, 1 would be the alpha, right? Okay. And then a VK render pass begin info, because of course there has to be another effing structure you gotta build. VK render pass create info, is that what it was? Begin info. Stack. Okay, pass begin info. Render pass. Render pass dot get. Okay, so render pass is render pass dot get ID. Clear values. Render area, so that's the window extent. Well, I guess really the image extent for the image buffer. So render area. Okay, rect 2D a dot extent dot set. Set with height. Right? Yep. And then frame buffer, get the frame buffer ID. And command buffer, begin recording. And then end recording. Okay. So we're actually recording the command buffer commands now, which is just basically just clear the screen. Or, well, fill the screen with a solid color. Okay, so command buffer begin recording. VK command begin render pass. VK command begin. Where's this at? VK CMD begin render pass. So command buffer get ID. The the begin info thing that we built. Okay. Wait, is it command buffer? Get VK command buffer. Did I forget to do a... Oh no, VK command buffer. I forgot to do a getter on that. There we go. Okay. Get buffer. The info and then VK subpass contents inline. Subpass contents inline, that's what it was. VK subpass and contents inline. Yep. And then end the command end render pass for that buffer. Okay. And end recording. Okay. Okay. That's the record command buffer. So we just have to do this line here. Stack. Command buffer, frame buffer with height. All right, so we have that. And then there's a public void submit that takes the queue, which I don't have. Well, no, it takes a queue, which I do have a queue. It's taking the interface. It's really, I have the basic queue. Although it's calling queue.submit, which I don't have yet. So public void submit. Public void submit. Base device queue, and memory stack. So index swap chain get cart frame. Get current frame. What the hell is it getting that? Swap chain get current frame. We don't have a current frame yet. Get sync semaphores list. Oh, we haven't integrated the swap chain and semaphores and stuff yet. Right, that's coming up. Okay, so I can't finish this method yet. So we'll just say finish method. And wait for fence. Public void. Fence. Swap chain, get current frame. I don't have a get current frame yet, so I can't do this either yet. That's fine. What I do want to do is public void cleanup. So we go through, clean up all the frame buffers, and clean up the render pass. So frame buffers for each. Actually, it's it's called cleanup, and then render pass cleanup, and then command buffers, and then fences. Go. Okay, so we have that. We have most of this in place right now. We're gonna have to do. What's the next one that wants me to tackle though? I think it wants me to add that to the render. So we got forward render activity. Forward render activity, right. And then we're adding that to the render class. Also adding up the cues in there, which are command pool. Q family index, right, okay. This I think I'm gonna do command pool forward render activity. So command pool is there, and then forward render activity at the bottom. Forward render activity. Okay, so command pool forward render activity. Wrong one. Right. Where's the... Oh, here it is. I saw renderer and I opened the wrong thing. Command pool. So this dot command pool equals new Vulkan command pool device and graphics queue. So device. Graphics queue. Not get Q, is it? Get Q family index. Graphics queue. Did I not do that? Okay. This dot forward renderer. Swap chain command pool. Initialize yet, I know. I know. So then render activity. So after device wait idle. Oh, there's new stuff in cleanup here. Graph queue wait idle device wait idle. Wait idle. And then, okay. So render forward render cleanup and then command pool cleanup. And then swap chain, surface device, physical device instance. Surface device. Device also does physical device, so I don't have to worry about that. Instance, okay. And then render now has stuff in it. Forward. So what are we doing here? Render activity. Wait for fence. And then image index, swap chain, acquire next image, which I don't think we haven't done yet. Okay, so to do image index here. And forward render activity submit. That's for the graphics queue. And then swap chain present image. Okay, to Swap chain present image or present image, whatever they, however you want to pronounce that. Okay, so I've got some of those stubbed out. So it looks like we need to make the additional changes here. Render. Okay, command pool. Q present Q. All right, so let's do the present Q. Very similar to sort of free up and clean up. We need to create another queue which will be used to enqueue the swap chain images which are ready to be presented. This queue uses a specific queue family which is used just for presentation. Oh, you know what? I'm going to call it presentation queue. So I don't get confused. Because that's just... Number one, that's laziness. Number two, it doesn't... You're like, is it present queue? Is it present queue? Or is it presentation queue? You know, like, it doesn't... Am I getting a gift? Am I talking about present time? Or am I talking about presentation, right? Like, it's just like, naming is very important when you're trying to learn something or come back to something later. Very similar to graphics queue. Okay. So, and then that gives you a family index. Get present queue family. Oh. Isn't there a... So this is where I did that other thing. Okay, now I see. Hang on. The graphics queue. No, I don't have it here. I thought I had a get graphics queue index. No, this is I do have it here. Get graphics queue family. Yes. Yes. Where the hell did I put this? In physical device. Okay, so let me see here. Hey, Premier. Oh, hey, Varuna as well. Sorry, I missed both of you. Welcome on in. And thanks for the compliments on the haircut. I appreciate it. It's the only kind of haircut I know how to do. I did it myself, so I'm like, this is the only way I can be sure that I've done it properly, is to just get rid of all of it. Welcome on in, everybody. Welcome. Vulkan render. What am I doing? So the graphics queue. Let me just make sure something here. What did they do? They have queue. Get graphics queue family index. Right. So I integrated that with the device because it was just the same exact logic. So what I could do is, okay, now I understand what this is being used for. Although this is a private method. So, and this is private as well. So what are they doing here? Get XQ family index. Because they're using that for the render here, right? Get. Don't they call this? Yeah, get Q family index. GraphQ get Q family index. So oh, I see. They put it at the Q level. Q family index. And which actually, okay. No, so that's part of the super. So don't I should have that then. Don't I? What the hell am I doing here? Base device. Q family. Oh, see, okay. Okay, so I take it in, but I don't, okay. All right, I think they've changed that there, so private, what did they do with it? Private final int Q family index, yeah, okay. I see here. Been working that you off earlier. Yeah, there you go. Nice. Okay. Let me see. So Q family index. So then I should be able to just do Q family index right there, and then I could just put a getter here for that. Okay, so that now makes some semblance of sense. Cannot assign. Oh, right, because I didn't do it in the I didn't do it in the constructor. I don't care. Do it this way. Sure. Okay, so we got that. So then, when I'm doing this, new command Q, GraphQ get Q family index. Okay. So graphics Q, get Q family index. There we go. All right, so that's now there. And then I need to make another queue called the presentation queue. All right, so have that over here. All right, that's good. Okay. All right, so presentation queue. They're going through and finding sports presentation, physical device. I don't know if I've done this before somewhere, but we'll just do it in here. So this is a private static. Okay, so presentation queue extends queue. All right. Vulkan graphics queue device. So Vulkan. Oops. Presentation queue extends base device queue. So public Vulkan graphics queue, not Vulkan graphics queue. Vulkan presentation queue. Logical device, surface, and queue index. So logical device, surface, and queue index. Okay, good. So presentation. Okay. And then we're just calling super there. But let's do private static int get presentation queue family index. Private static int get queue index. Get queue get family index, whatever. Device surface. Okay. Device surface. Okay, and then what? Index is -1. Try memory stack equals memory stack push. Physical device. Props buff. Int buffer. Number queue. Families. Is this another one that is... Again, why wouldn't I just... If this affects the physical device, why wouldn't I just put this method on physical frickin' device? Which is what I did with the other one, right? Graphics queue index. Yeah, I use iterable utilities. Yeah, why? Public int get presentation queue index. Right, because it's just looping over the queue family properties. Right, so int index equals iterable utils index of queue family properties, and then we're looking for number RQ families. Okay. And then what? We're calling... okay, it's a little more complicated, but we gotta say... get physical device surface support. KHR. Buffer. VK true. Physical device support. Okay. So... alright, so it's a little more complicated, a little more involved. But I think this still works. So I have to say, so I need the int buffer and stuff. Okay, fine. Try. Do that. And do this, and then int buffer. Right. Then KHR surface, get physical device surface support. Okay. So KHR surface. Get physical device surface support KHR. Get physical device surface support KHR. Okay. And then the physical device ID. We literally have to pass it the index. Oh, that's why they're doing a traditional for loop. That sucks. Okay. Just do a physical device. Why is that? Get VK physical device. Did they? VK physical device. I don't have that on there. Oh, I have the actual VK physical device. Okay, so never mind. I hate this. I hate it. I hate it. So I surface get VK surface and then int buff. Surface. Why is that not a thing? Do I have surface in here? I guess not. So I have to pass the surface in. So I wonder, this iterable utils, do I have access to the index in here? I don't think so. One if none matches. Predicate. Apache iterable utils index. Index of access. Access index inside predicates. No, I'm asking too much of Google. Index of so I'm guessing that's going to be a no on that. Variable to be search. Predicate to use must not be null. Negative one if none matches. Null or empty iterable returns negative one. Looping iterable returns a view of the given iterable which will cycle infinitely over its elements. Oh, that's interesting. That's an interesting way of going about it. Okay. I wonder, let me see something here. Yeah, it's just giving me the object, right? This is a janky way of doing it, but it'll work, hopefully. It's not going to let me do it because it wants I to be final, right? Frack. Frack, frack, frack. Alright, well, we just gotta do it the old-fashioned way. Was hoping to do it cleaner way, but nope. I is 0, I is less than. Family properties that count. All right, I think that's. Whoops. Where are we looking at here? It's doing capacity. Does this have the capacity on it? Yeah, okay, we'll do that. Capacity, and then I just call this and then we have to check the Boolean. Sports presentation. So that's buff. Get 0. Equals VK 14. Okay, true. What's even the point of doing Dex I? Yeah. Matching index. And then index is less than 0, runtime exception, otherwise return index. Unable to find any presentation Q family index. Right. Okay. Q family index. So get presentation queue. Next. Okay. So, and that's in physical device now, which is probably where it should be. So then in here, I don't need it. Well, no, I don't need it there per se. I do need, well, we'll say super, what am I doing a super here? Device. And then, how did I do the other one? Get physical device, get presentation queue index for that surface, and then queue index, right? What's going on here? Q family index, Q index. Oh, because I'm doing crate Q, that's why. I didn't do the super, I did crate Q. That's why. Alright. Cool. So that's our Vulcan presentation queue, but then do I need to call? I don't think so. Let's go back to render here. We got the presentation queue there in render. So private final presentation queue. And then we're saying presentation queue device surface 0. Right after the graphics queue. Okay. Device surface and then 0. Okay, presentation queue, and then that's the first one in cleanup where we do wait idle. Okay, and then that's it there. But we'll probably need the presentation queue for, that's for swap chain. So then I need to do the swap chain changes, I'm guessing. Where it takes the it takes semaphores and concurrent queues. Swap chain. Let me see what this takes here. Render, for render. Swap chain. Wait a minute. What are we doing? Render. Defines 2 new methods to acquire and present the used images. There also changes swap chain constructor. Okay, so swap chain is doing both of those. So the presentation queue and a list of concurrent queues. Where is this? Where's this used? Concurrent queues. Number of queues. Queue family index. Oh, I see. Okay. Get queue family index. So it's getting all the indexes of things that are not presentation queues. Putting those into concurrent queue. No, putting those into indices. And then it's fuck are they doing? Wait a minute. Number of queues. Concurrent queues. My night's going good. Everything's been pretty good. We're making progress here. I've been trying to kind of get to the end of chapter 5 here of this Vulcan book so I can actually get a solid color on the screen, but it's looking like there's a pretty big hurdle right at the end here, and that's like making all these little changes to things that we've already established. And I'm getting the feeling like I'm not going to be able to really do that right now because I can feel my brain already starting to give up. Let me see. But otherwise, it's been good. It's been productive. Very much so. Concurrent queues is not null. Then get the length of it, otherwise 0. Concurrent queues. If the concurrent queue is not equal to the presentation queue that was passed in, then add it. Okay, so if they pass the presentation queue in there, then ignore it. Okay, and then it's malloking this, and then in buffer put presentation queue get queue family index flip. Image sharing mode concurrent. Family index count queue family. Have different queue family index than the presentation queue. In that case, we need to change from the sharing mode exclusive to sharing mode concurrent and include in a buffer all the queue family indices that require concurrent access, including the presentation queue family itself. Okay, in addition to that, we need to add more changes in constructor to create as many semaphores as images as we have for the swap chain. Okay, I don't know why I'm doing this, but I guess that's in order for those concurrent queues to have access to the presentation queue, they have to be associated with one another, I'm guessing. Is what's happening here, but that it's not immediately making sense. Everything seems to be neat in the coding. Yeah, it's coming along. Like I said, I mean, at the end of this, I should have... Yeah, there's still a big jump here. But I'll have something like this, although it won't be the blue background. I've made it a black background, but I should have something like that when I get done wiring up the rest of this stuff here. Which I think I just have to wire up the things in swap chain, and then is there... I did forward render activity. Although I think there's still some to-dos in there that I have to do once I get the swap chain stuff. And like around submit. because it brings in things. Okay, so yeah, all right. I hate to do it, but I'm gonna have to probably stop there because it's I'm at a point where I know that there's another big jump here where I gotta like start wiring things together, and my brain just can't handle it right now. It doesn't look like there's there's a lot I have to do left, but I'm almost betting that as soon as I wire up these final things, something's going to be broken. I can almost guarantee that. But this is good. We've made. I mean, look at all the progress we've made here with all the new classes and stuff. So definitely haven't slouched today. Let's go, and I'm just going to commit what I've got. So we'll say almost finished chapter 5 of Vulcan book. And I'll get those in there right now. All right, cool. Well, that's out there. It's it probably won't build. I think it said it had one error, but that's all right. We'll get to it. But I'm gonna have to stop there for right now. Come back to this, I guess, next weekend. Friday and Saturday. We'll probably finish this Friday night. At least finish chapter 5, and then hopefully we'll have something to show for it, at least a blank screen to show for it. And then I got to figure out, I think it's chapter 9 where we actually start loading up models and stuff. So I'm gonna have to figure out like what parts of chapter 6, 7, and 8 I need in order to build on chapter 9 there. So we'll have to see. And then I'll keep working on the here and there on the Mango HUD thing and see if I can figure out why it won't connect to my OpenGL one. Why I can't get it to hook my OpenGL code. But all in all, I'm happy. I think we've made some good solid progress here. Hang on, let me get that. I don't know. I know I've been saying that I'll probably stream tomorrow because I missed a day this week. I have to finish up stuff for work, though. I don't know. I might stream at night. I might stream for a little bit at nighttime. We'll see. It really depends on what mindset I'm in, because there's just some things I have to finish for work, and I might by the end of it just be so tired that I don't want to deal with anything or anybody. So that might be a thing. So we'll see. It'll be an unannounced stream. So if I do stream, it'll just be a spur of the moment thing or not. We'll see. But I can say at least Monday night, I should be back with some Sniper Elite. Try to finish up Sniper Elite if I can, or at least I don't know if we'll finish it. We're getting close to the end, but I don't know if we'll completely finish it because I do want to do the DLC one as well, which is just I think one map. But so we'll see you on that one. But we'll at least get very very close to the end, if not all the way through. And then Tuesday and Wednesday we'll be back doing more Avowed. Trying to get that. Just keep on moving forward on that. Enjoying my time in that so far. Thursday, hopefully, will be some Grim Dawn, doing the DLC stuff. And then next Friday and Saturday we'll be doing more game dev stuff. I will eventually get back to the streamer bot thing because I really want it for myself. But it's going to be I need some time myself to just sit down off camera and just kind of blast through some of the stuff in there and see if I can make some progress. Because I need to be able to focus to do that. Focus a little bit better, I think. And right now, we're in like production run right now, where it's like, you know, at work I have a bunch of things I need to get done for because we do production stuff. We do production releases twice a year, and this is one point of time. So we're getting down to the wire on that. So, and I have a bunch of things I need to fix. So I probably won't have any time outside of work to look at it. Until I can get through like what I have left, which technically I don't have a whole lot left, but every time I try to get to what I need to get to, something else comes up. And that's kind of where I'm at right now. So we'll see on that. Hopefully by this time next weekend I'll be a little bit more in the clear with a bunch of that stuff. So just hoping beyond hope with that. Yeah, I think that about covers everything right now, my friends. I do have some more things I have to configure Mix-Up-Bot some more and a few other things along the way here for now. But yeah, we're good. We're good. If you happen to run across this on the old YouTubes, I would, and you have a like or a subscribe that you can spare, that would be really swell. It helps out tremendously. Otherwise, my friends, I don't know, is there anybody, is there anybody live right now? Let me take a gander. I don't think there is. There usually isn't. No, I don't see anybody. So I'll let you guys disperse on your own and say thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you, and hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
is the way.